So you can actually see critical angles properly by going underwater and either shining a light or having the sun shine down on you, and you get this thing known as Snell's window. So it's just a circular disc of light that, well, obviously when light hits the water at the critical angle, it creates the largest possible disc. The critical angle of water tends to be about 47. And by using this property and some trig, we can determine a lot of quantities related to this particular circular disc. So I'm going to walk through one example, and then I'm going to show you another example on the next slide. So I'm going to show you how to do it first, because it is a bit whack. So a diver is located 2 meters below the surface of a lake. He shines a light from that depth and creates a circular disc. Given that the index of refraction is 1.33, find both the critical angle of the water and the radius of the circle formed. So, obviously you can go ahead and try it if you really want, but here's how you do it. So you can imagine a diver on the bottom, and he shines a light. Oops, that shouldn't be there. Oops, oh my god. I was trying to draw his arms, but I guess I kind of drew them in the wrong place. There we go. He shines a light so that it hits the water at the critical angle. Now remember, it's from the normal, so the index of the critical angle will be here. So that's alpha c. Now what we can also do is we can draw a transversal here, or just a line parallel. So these two lines are parallel. And because we let this be a right angle, this will also be a right angle. Because we have z angles, this angle in here will also be alpha c, which allows us to get the particular radius. Ross Little is 2 meters below the surface. So 2 meters is that distance there. So the critical angle of the water, well, we're told it's 1.33. So for part 1, so 1.33 is 1 divided by sine of alpha c. So I'm going to skip a couple steps here. So we'll do sine inverse of 1 over 1.33. We get, well, it has it to 3 significant figures, so we'll do 48.8. So I did say on the previous slide, or one of the previous slides, that the critical angle of water is about 47. This could be slightly, or water with slightly higher alkalinity, for example. So that's the critical angle. Now the radius of the circle formed. So if I just draw a little triangle of what's going on here, that there is alpha c. That's the radius, and that's 2. We know what alpha c is. We know it's 48.8. So what we can say is that tan of 48.8 is the opposite over adjacent, so r over 2. So r is just 2 tan 48.8, which is 2.28. So 2.28 meters. And it just asks us for the radius, and that is the radius of the circle that is formed due to Snell's window.